Exercise 8.2. First question for AP board students. Equilateral triangles are drawn on the three sides of a right angle triangle. Show that the area of the triangle on the hypotenuse is equal to sum of the areas of triangles on the other two sides. So here let us take a right angle triangle. Right angle triangle. It is given here. Okay. So this is 90 degrees and this side is called hypotenuse. What is given here? There are three equilateral triangles. Three equilateral triangles are drawn on the three sides of this right angle triangle. But here one equilateral triangle is taken on the hypotenuse, is drawn on the hypotenuse. Okay, my dear students, here just imagine this is a triangle, equilateral triangle. This equilateral triangle is drawn on this hypotenuse. Okay, I will draw again. Right. See, this is ABC is a right angle triangle. What is the hypotenuse here? AC is the hypotenuse. So here, my dear students, this is an equilateral triangle which is drawn on the what? On this hypotenuse, right? So let it be some S, ACS. Okay. Now this is another equilateral triangle which is drawn on the what? The side BC. So let it be some T, right? Now we draw another equilateral triangle like this. So this is P. Here this is an equilateral triangle APB. This is an equilateral triangle ACS. Right. So here there are three equilateral triangles. Okay. The first one is ASC. This equilateral triangle is drawn on the hypotenuse. And this equilateral triangle is drawn on the one side of the right angle triangle. And this is also same, one side of the right angle triangle. Okay. See, my dear students, before we start this proof of this theorem, let us learn what is the area of an equilateral triangle. Area of an equilateral triangle. I will write here. Area of an equilateral triangle. Equilateral triangle. This is root 3 by 4 into a square. This is root 3 by 4 into a square, right? Root 3 by 4 into a square. A is the side of, equal side of an equilateral triangle. Equal side of an equilateral triangle, right? So all the three sides are equal now. So each side is equal to small a units. So this is the area of an equilateral triangle. Okay. See, coming to this three triangles, what we have to prove here? What we have to prove? To prove the area of this triangle. Area of triangle ASC is equal to area of triangle BCT plus area of triangle PAB. So that means the area of what? Triangle which is drawn on the hypotenuse is equal to area of the sum of the areas of two triangles which are drawn on the other two sides. Right. So we have to prove this one. So I forgot to write. What is given? PQR is a right angled triangle. Right angled triangle. PQR is a right angled triangle. Okay, my dear students. Now look here. See, what is the area of an equilateral triangle? Root 3 by 4 a square. Okay. So what is the area of triangle? ACS. Triangle ASC. ASC. So let us take each side of this equilateral triangle is AC only. That means root 3 by 4 into AC square. AC is the side. This each side of this equilateral triangle is equal to AC, right? So AC is equal to SC is equal to AS. Therefore, this each side of an equilateral triangle is equal to AC. That means root 3 by 4 into AC square. Okay, my dear students. Coming to this triangle, area of triangle BCT. This is also equilateral triangle now. This is root 3 by 4 into. So here all these three sides are equal to BC. Sorry, all the three sides are equal. Here I have taken each side is equal to BC. That means root 3 by 4 into BC square. Root 3 by 4 into BC square. Right. Now here, what about this area of triangle APB? APB. This area of triangle APB is equal to root 3 by 4 into, here this each side is equal to AB. So root 3 by 4 into AB square. Okay, my dear students. Okay. So this is equation 1, this is equation 2, this is equation 3. We will take only this area of triangle ASC. This is root 3 by 4 into AC square. But this root 3 by 4 into this AC square can be written as AB square plus BC square. AB square plus BC square. Okay, my dear students. Why? According to Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Actually, this theorem will be in the next exercise. Exercise 8.4. Before it will come, right? So instead of this AC square, we can write AB square plus BC square. Now, my dear students, here, this root 3 by 4 AB square, let us multiply with root 3 by 4 AB square. Again, this root 3 by 4 BC square. So this is equal to root 3 by 4 AB square is the area of triangle APB. Similarly, this root 3 by 4 BC square from equation 2, this is area of triangle BCT. So this is from equation 3 and 4. Sorry, from 3 and 2. From 3, and this is from 2. This is from 2. Okay, this is from equation 2. Right. From 2, right. So this area of triangle ASC is equal to area of triangle APB plus area of triangle BCT. APB plus area of triangle BTC. These two are what? The sum of the areas of triangles on the other two sides of this right angled triangle. It's very, very simple. Don't confuse. Just I have taken only these 3 steps. Area of triangle ASC means root 3 by 4 AC square. Area of triangle BCT means root 3 by 4 BC square. Area of triangle APB is equal to root 3 by 4 AB square. Here you can write the reason here. The reason is here, this AC is equal to what? AS, and it is also equal to SC. So all these 3 sides are equal. So I have taken only AC, right? So this is root 3 by 4 BC square. BC is equal to what here? Since BC is equal to CT and BT. BT and it is also equal to CT. Here this AB is equal to what? Since AB is equal to AP and BP. Right. Because of this reason, this triangle area is root 3 by 4 AC square, this triangle area is root 3 by 4 BC square, this triangle area is root 3 by 4 AB square. So take area of triangle ASC, this is root 3 by 4 AC square. This AC square can be written as AB square plus BC square according to Pythagoras theorem, since ABC is a right angle triangle. Okay. So this is now we can multiply with root 3 by 4 AB square plus root 3 by 4 BC square. This is area of triangle APB plus area of triangle BCT. Okay, my dear students. So hence it is proved. Hence it is proved. Okay. Second question in exercise 8.3. Prove that the area of the equilateral triangle described on the side of a square is half the area of the equilateral triangle described on its diagonal. Okay. What we have to prove here? There is a square. This square, the area of the equilateral triangle described on the side of a square. That means there is an equilateral triangle which is described on the side of a square. Okay. So here that ABCD is an equilateral, square. Given this ABCD is a square. This ABCD is a square. So here AB, BC, CD and AD is equal to small a units. Okay. This is given. What is to be proved here, my dear students? To prove here the area of an equilateral triangle described on the side of a square is half the area of triangle described on its diagonal. That means here this area of triangle, this described on the side of a square is half the area. Half of the area of an equilateral triangle described on its diagonal. That means there is any other equilateral triangle which is described on this diagonal of a square. Okay, I will explain clearly. Wait. Here, since it is an equilateral triangle, ABCD is an equilateral triangle. Sorry, ABCD is a square. Since ABCD is a square, so here all the sides are equal. AP, BC, CD and AD all are equal to small a units. This is let. All the sides of an equilateral triangle are equal to small a units. Okay, here this is small a, this is small a and this is small a, this is small a. So this triangle ABCD, this is E, let it be E. This is an equilateral triangle which is described on the side of a square. So DCE is an equilateral triangle with sides small a units only. Why? Here this side is DC. DC is the side of an equilateral triangle. It is also the side of what? Sorry, DC is the side of a square. So this is also the side of an equilateral triangle DCE. This is also the side of an equilateral triangle DCE. Okay, that means here this small a is equal to all the sides of this equilateral triangle DCE, right? Okay, so coming to the triangle DCE, in triangle DCE, DC is equal to DE is equal to what next? This CE all are equal to small a units. The reason is this equilateral triangle is described on the side of square ABCD. Okay. Okay, all these three sides are also equal to small a units. So what is the area of triangle DCE, my dear students? As I told you in the previous problem, the area of an equilateral triangle is root 3 by 4 into a square. That means here this is root 3 by 4 a square. This is equation 1. So this area of triangle DCE is equal to root 3 by 4 a square. Why I have taken a square here? Since the side of an equilateral triangle DCE is a units. Right. Now coming to this, DB is the diagonal. Diagonal means it's a line segment joining the opposite vertices of a quadrilateral. Here the quadrilateral means square. Right. Now here we have to draw a what? Another equilateral triangle. Another equilateral triangle which is described on this diagonal. Okay, my dear students. So here this BD is what? BD is a diagonal of a square. This BD is a diagonal of a square. Okay, what is this triangle here? This FDB. Can you see here? This is FDB is a triangle. Triangle FDB is an equilateral triangle. This is an equilateral triangle. This FDB is also an equilateral triangle, but this triangle is described on the what? Hypotenuse of the square ABCD, right? Okay, my dear students. But do you know the length of this hypotenuse? Diagonal. Do you know the length of this diagonal, my dear students? Do you know the length of the diagonal of this square ABCD? That means this is BD. The diagonal is BD here, right? We don't know. But take the triangle. In triangle ADB, this angle is what? 90 degrees. Why it is equal to 90 degrees? Each angle of a square is 90 degrees. Therefore, this angle is right angle. So, ADB is a right angle triangle. So, we can apply what? Pythagoras theorem. That means DB square is equal to AD square plus AB square. Okay, my dear students. So now here this AD is equal to small a, AB is also small a. That means DB square is equal to A square plus A square. Of course, this ADB is an isosceles triangle. Why? These two sides are equal. We are going to find that what? The hypotenuse of isosceles triangle or the diagonal of triangle, the diagonal of square ABCD, right? So this DB square is equal to 2A square. DB is equal to what? My dear students, what is DB? DB is equal to square root of 2A square, that is root 2A. So this is root 2A units. So what is the length of the diagonal of square ABCD? Root 2A units. Okay. Now, what is the area of triangle ADB? ADB means it is an equilateral triangle. So, what is its area? Root 3 by 4 into A square. A square means root 2A whole square. Okay, my dear students. Now, we have come to the end. Conclusion, right? This is root 3 by 4 into root 2a means square and root get cancelled, that is 2a square. Root 3 by 4 into 2a square. So here this 2 in 4 two times. This is root 3 by 2 into a square. So it is equal to root 3 by 2a square. This is the area of triangle ADB. But what is the area of triangle DC here? Root 3 by 4a square. So here, my dear students, if you multiply with this half into this root 3 by 2a square, that is equal to root 3 by 4a square. Am I right? This area of triangle DCE should be equal to half of area of triangle ADB. So this is equation 2. Therefore, from 1 and 2, area of triangle DCE is equal to area of triangle DC. Can you see here? Area of triangle DCE is equal to, that means root 3 by 4a square is equal to half into area of triangle. This equation is equal to this equation when it is possible, when it is multiplied by half. That means half of area of triangle. This is ADB. Area of triangle ADB. Half of area of triangle ADB. Half of area of triangle ADB. I hope you understand here. That means the area of a triangle, equilateral triangle described on the side of a square is equal to half of the area of a triangle which is described on its diagonal. Why? This is root 3 by 2a square, this is root 3 by 4a square. This root 3 by 4a square only it is equal when this root 3 by 2a square is multiplied by half. That means this area is equal to half of the area of triangle described on the equivalent triangle described on the diagonal of a square ABCD. Here third sum. Third sum in exercise 8.3. DEF are the midpoints of sides BC, CA, AB of triangle ABC. Find the ratio of areas of triangle DEF and triangle ABC. Okay, here what is given? What is given here? ABC is a triangle given in triangle ABC, D comma E and F are the midpoints. Are the midpoints of BC, CA and AB respectively. These are the midpoints. Right. What is to be proved here? To prove, nothing to prove here. We have to find the ratio of the areas of two triangles DEF and ABC. Okay, let us take the triangle here. Actually, this ratio is equal to 1:4. So ABC is a triangle. Here this DEF are the midpoints, DE and this is F. Okay, my dear students. See, we know that already you have learned in class 9. We proved this theorem in class 9, but it's a long process. We prove that this is a parallelogram, this is a parallelogram, this is a parallelogram, and what else? Each diagonal divides the parallelogram into two congruent triangles, and if two triangles are congruent, then the areas are equal. Like that we proved. It's a long process. But here, after we learned that theorem, previous theorem, so it's very simple. It became very simple. We know that what we know in class 9, what we have learned, a line segment joining the midpoints of any two sides of a triangle, line segment joining the midpoints of any two sides of a triangle is parallel to third side, and also half of it. That means, my dear students, this FE is, actually, did you understand this theorem concept? A line segment joining midpoints of any two sides of a triangle is parallel to the third side and also half of it. That means this FE is equal to half of BC. Similarly, this DE is equal to half of this AB. Similarly, this FD is equal to half of FD is equal to half of AC. So from these three equations, what do you write, my dear students? FE by BC. FE by BC is equal to 1 by 2. FE by BC is 1 by 2. Similarly, DC by AB is also 1 by 2. DC by AB is also 1 by 2. Similarly, AC by FD, it is also 1 by 2. Okay. So from the above equations, what do you write? FE by, first we start DC by AB, next FE by BC and AC by FD. This is equal to 1 by 2. No, from above equations, this DC by AB, FE by BC, AC by FD, all these ratios are equal. The corresponding sides are proportional. That means triangle DEF is similar to triangle triangle ABC. Therefore, if two triangles are similar, this is according to SSS similarity. Therefore, if two triangles are similar, Area of triangle DEF by area of triangle ABC is equal to what? DE square by AB square, EF square by BC square, DF square by AC square. That means this is equal to what? 1 by 2, no my dear students. This is 1 by 2 whole square, that is 1 by 4. 1 by 2 whole square is 1 by 4. That means the ratio of the areas of two triangles. What are the two triangles? One is, it is formed by the midpoints of the sides of the triangle, and the other one is the original triangle. They are in the ratio of 1:4. I hope you understand today's class. If you have any doubts, please mention in the comment box. Thank you very much.